Okay guys, what we're going to look at now is what the textbook calls the area theorem. Now, you will do this again in the upper years, and in the upper years we call this the side times height method or the base times height method. So I'm going to call it that because it actually makes more sense. I find the area theorem a little bit vague, okay? It's not very clear for you guys. Okay, so what this means is, if we have a triangle, let's draw a triangle like this. Okay, now in that triangle, we know that this triangle is a right angled triangle, and we will make this side, say, 6 and this side 8. All right, now what I want to know is what the height of this triangle is. This is the height. We want to calculate what the height is. All right, now this works because it's a right angle triangle. It will work in any triangle, however, not quite in the same way. So because we have a right angle triangle here, and we know the 6 and the 8, we can, in theory, we can look at this as if we flipped it. Okay, so what we can do is, I'm going to draw this triangle again. Okay, we can pretend that it's sitting this way. Okay, we can pretend that it's sitting on its side like this. Okay, and then once we've done that, we have 6 times 8 like this. Okay, now you guys know that the area of a triangle is equal to half times the base times the height. Okay, this is the area of a triangle. Okay, and the triangle we have has a base of 6 and a height of 8. Okay, so for example, this triangle here, when we flipped it, we can say that the area is equal to half times 6 times 8, which is equal to half of 48, okay, which is 24 centimeters squared. Okay, so we know that this is the area of the triangle. We're going to use that now to find this height. Now, you're going to have to double up with this because we can now look back at the original triangle again. So we're looking back at the first one we drew. We have here a base, and we're trying to calculate the height. So this is the base and the height again, but looking at it from a different side. Okay, so the first example of base times height was just using the two sides of the right angle triangle. Now we're looking at the base times height, looking at it from the other direction. Now, what we can do here is, we know that again, area of the triangle equals half times base times height. Now, firstly, we don't know the base in this one. Okay, we want to find the height. Okay, so we want to find this h here. And that's the thing I've highlighted in yellow. But in order to do that, firstly, we do need to know that base. Okay, now, that base, we can use Pythagoras to work this out. Okay, so the base is the hypotenuse of our second triangle. So we can say b squared, because this time it's our base, is equal to a squared plus c squared. Let's just call them a and c for the moment. Okay, now a is 6 squared plus c is 8 squared. Okay, so b squared is equal to 6 x's are 36 plus 64. B squared is equal to 100. So b is equal to the square root of 100. B is equal to 10. Okay, so we know now that our base here is equal to 10. Now, going back to what we said at the start over here, so going back to looking at this area, because we're trying to find the height, we know that area equals half base times height. So area is half times the base, which we just said was 10, times the height. We still don't know the height, but one thing we do know is we know the area of the triangle because we already calculated that over here. Okay, we calculated the area, so we know that 24 is our area. So 24 equals half by 10 by h. Okay, so 24 is 5 times h. Okay, and the height is just 24 over 5, or 4 and 4/5. That is our height. Now, this is all a little more complicated than we need. Okay, we don't need to go through all of this. We do need to use Pythagoras. That has to happen regardless. Okay, but basically what we want you to get out of this is, if you know the base times the height, it's always equal to another base times height. Okay, and that's why I have called this the base times height method. Okay, because the base times height from one side, let's redraw the triangle again. Okay, this is not a very nice right-angled triangle, but it will do. Let's call this A, B, C, D. Okay, so in this triangle, our two bases are AB times the height. In this case, would, if AB is the base, then BC is the height. It's equal to our base, which from the other view is AC, times BD. Okay, so the base times the height. So let's look at it this way: the base times the height from one view is the same as the base times the height from another view. Okay, this is a little bit of a different theorem for you guys. Okay, and as I said, sometimes you might need to calculate something first. Okay, now we may also give you a case where we've already given you side AC. We might already give that to you. Okay, that makes it a little bit easier, but in the example I gave you, we needed to calculate that green base here first. So I will just put a box around that there. So firstly, we had to calculate that green base in order to do the rest of it. Okay, so as I said, it's a little bit strange, but this is how we can use this. Okay, so basically, if we know the area is never changing, the area stays the same, therefore that base times height will always be the same no matter which side you look at it from.